Sometimes we may want to compare two distributions to see if they are the same. The way to do this is with a test called the chi-square test of homogeneity. The null hypothesis H sub 0 of the chi-square test is always that the two distributions are the same, and the alternative hypothesis H sub A is always that the two distributions are not the same. Use a contingency table to help perform a chi-square test of homogeneity. The chi-square test statistic is the sum of the square of the differences between each observed value and the corresponding expected value divided by that expected value. This statistic converges to a chi-squared distribution with a parameter called the degrees of freedom. The degrees of freedom parameter is calculated by taking the number of rows in the table minus 1 and multiplying the difference by the number of columns in the table minus 1. Once we have the degrees of freedom and the chi-square statistic, we can use a chi-square table or a calculator to determine the corresponding p-value. We compare the p-value to a significance level, alpha. If p is less than or equal to alpha, reject the null hypothesis. If not, fail to reject the null hypothesis. Let's look at an example. A study was done comparing the support for a political candidate by men and women. 300 men and 250 women were sampled. Of the men, 104 reported supporting the candidate. This compares to 72 women who reported support. With a 0.05 significance level, are these distributions the same? First, create a contingency table with the data. Now, calculate the expected values. The expected value is the product of the row total and the column total divided by the total number sampled. The expected value for men who support, denoted E sub 1, 1, equals 300 times 176 over 550, which is 96. The expected value for men who do not support, denoted E sub 1, 2, equals 300 times 374 over 550, which is 204. The expected value for women who support, denoted E sub 2, 1, equals 250 times 176 over 550, which is 80. The expected value for women who do not support, denoted E sub 2, 2, equals 250 times 374 over 550, which is 170. Add the expected values to the contingency table. Now use the values to calculate the chi-square test statistic. Substitute and evaluate to get approximately 2.1569. We also need to calculate the degrees of freedom. The degrees of freedom is equal to the number of rows minus 1 times the number of columns minus 1. There are 2 rows and 2 columns, so 2 minus 1 times 2 minus 1 equals 1. Finally, use a chi-square table to estimate the p-value. There is 1 degree of freedom, so look at the row labeled 1 in the degrees of freedom column. The value 2.1569 is greater than 1.32 and less than 2.71. So, the p-value is between 0.10 and 0.25. Now compare the p-value to the significance level. A value greater than 0.10 is also greater than 0.05. Since the p-value is greater than alpha, fail to reject the null hypothesis. There is not enough evidence to conclude that the distributions are not the same.